Yes, but the fridge is not an isolated system and will heat up the room more than it will cool down the water, increasing the total entropy. Want to see some magic? Whoa, what just happened? Some electrons apparently moved through some wires and let there be light. What is going on here? Objects have a fancy something called a charge. It can be positive or negative, or if you have the same amount of both, an object is neutral. Electrons have a single negative charge. The flow of electrons is called electric current. To describe it, we use three parameters: current, voltage, and resistance. Current is the amount of electrons passing through a wire in a given amount of time. Voltage is what pushes the electrons to move, but simply put, it's a difference in electric potential, so you can imagine it as a slope that goes from high potential to low potential, where the flow of current goes downhill. And resistance is pretty self-explanatory. This is Coulomb's law. Wait a minute, this is just Newton's law of gravitation in disguise. This tells us that electric charges attract each other in a similar way masses do. Opposites want to cuddle, while like charges literally couldn't think of a more disgusting thing than to be with one another. These four equations explain pretty much all of electromagnetism, but don't be scared just because they look scary. I mean, yeah, they do, but it's simpler than it seems at first. The first one states that if there is an electric charge, there will be an electric field, or this big E, emerging from it. Add another and you have an electrostatic field. These lines tell us in which direction a charged particle would feel a force at any given point. The second one tells us the same for magnetic fields, and even though electric charges are cool and can be alone, magnetic poles are not. They're very lonely, and there will always be a north pole together with a south pole, and a single pole can never be alone. Okay, now here's where things get kinda freaky.